Well, hey guys. My name is Trisha Roetter, and I'm an unregistered architect currently working in an architecture firm in Bethesda. I graduated in May with my master's from the University of Maryland, and 2 years before that, I graduated from University of Kentucky. So I have my master's of science in architecture and a bachelor of arts in architecture. And I'm going to talk to you today about what architecture is and how I got to where I am and what I'm doing, and of course, how math is evolved in a lot of my jobs and studies. Not quite intense calculus or physics, but a lot more simpler day-to-day math, things you learn in algebra, geometry, trig, etc. So I grew up in the area. I'm born and raised in Rockville, and I went to Holy Cross. And while I was there, my last semester, I decided that I wanted to take a drafting class at Montgomery College. So I decided I wanted to take this class because I was basing all of my school searches off of doing architecture as my major in college. And I thought, well, if I'm going to go away to school, an out of state school, pay a bunch of money, I should probably figure out if that's the actual major that I want to do. So I signed up for this drafting class, and I started to learn some of how to take design ideas and translate it into technical drawings that then can be relayed to a contractor or an engineer or a developer, what my design intentions were. So basically, taking this class to figure out if I wanted to do architecture as my major, which it ended up I did. I really enjoyed it. I learned some of the beginning of the technical, but then from there, I went to University of Kentucky in Lexington, Kentucky, and here is where I started to learn what architecture really is. So if I were to ask any of you what architecture is, I would assume that you would say something along the lines that it's designing or building buildings, and I would say that you're correct, except there's a lot more behind it, and we typically don't actually do any of the building part. So at Kentucky, I started to learn that architecture is creating a habitable space. And by that, I mean that architecture is creating a physical space in which someone can physically connect with people, emotionally connect with people, experience different things through interactions or performing certain tasks, etc., etc. So there's a lot of different components that go into designing a building. And while in my undergrad at Kentucky, I started to develop some of these skills, starting to hone and understand how these start. And so I started to understand how to translate an idea in my mind into something graphically displayed, whether it's someone that's in our profession or someone who isn't. It had to be something that's understandable. So I learned a lot about proportions and perspectives and material choices, data collection, and how all these parameters can be translated into spaces that are part of, or more importantly, purposeful So I learned a lot about proportions, perspectives, material choices, data collection, and how all these parameters can be translated into spaces that we're a part of. But more importantly, purposefully making decisions to create an intentional design. So in our profession, one of the big buzzwords is a kit of parts. And it's essentially saying that a building is comprised of many different parts and pieces. And they all come together and form one singular entity. And so that is the building, of course, the piece of architecture. So maybe an easy way to explain a building in relation to math is to think of one large equation that has many different variables you're solving for. So you break this equation down into smaller parts and pieces, solving each bit while always relating it back to the larger picture. So if you start to figure out one piece and the next piece, and then you go back and change parts of it, then the following steps or pieces will be changed as well. So you're creating a new solution to the general equation. While at Kentucky, I spent 6 months in Spain studying at the Institute of Advanced Architecture in Barcelona. And so here was where I got the first peek at architecture's deep connection to technology and data. Studying abroad gave me an opportunity to experience an environment that was much different than the place I grew up, but it also helped to develop my view on global architecture and the way that it has impacted in the way I see different cultures. Or let's rephrase that. It helped to develop my view on architecture globally, and it has impacted the way I see different cultures and how architecture is influenced by that. A lot of what I was doing while there and studying was collecting data, creating algorithms, essentially coding and translating all this data that I was gathering into a structure or an environment that based on that data became a space that somebody could inhabit. So getting back to math and how I was viewing this in a math perspective, I was taking in data and information, calculating or formulating or creating parameters that would give me a controlled output, a design, a product, a structure, a building, a habitable space. So in working with data, a lot of my design decisions actually came down to mathematical equations and working them out to get to the end result that I was envisioning. And so when I got back to Kentucky, I still had a year and a half of undergrad left, and so I continued taking classes like robotics for fun on the side, although very difficult. But I also had a lot of classes, that I was required to take, like environmental controls and physics. And in environmental controls, we studied, obviously, ways in which to control the environment around us. So whether that be an interior space inside a room of a building, or an exterior space, so the outside spaces such as a patio or a courtyard, we were learning how we have to understand how to control those spaces. And so then in physics, we were learning and studying how to build the structures and the safety of those spaces. We learned about all sorts of ways, from what is the best lighting, how to calculate the light brightness, how to distribute light in a room, how to properly locate and size mechanical equipment, knowing how much air and at what force it should be pushed into a room, how large a column should be, whether that column and the beam above it needs to be steel or wood or concrete. All of this knowledge that I was studying in my classes, from robotics to design to history and culture to mechanical and structural, I took with me as I completed my 4 years at Kentucky and moved on to Maryland, where I continued my studies in architecture for another 2 years. I completed my program with an individual thesis project at Maryland. And what that means is basically I took a social problem and solved it through architecture while research and developing it for about a year. And so taking all my experience and my studies and translating it into a building comprised of all these bits and pieces that I've been discussing throughout. With that kind of overwhelming and very, very brief backstory of how I got to where I am, I thought I'd wrap up with just talking for a few minutes about what my firm does and what I do on a daily basis. I work at, like I mentioned, SK&I architecture firm, and we do residential architecture mainly in DC and Bethesda, but also in several large cities in the US, like Atlanta and Boston and Nashville. And so how the process works is we get a client, or in the case of the project that I'm about to talk about, we have a developer that wants to build an apartment building. So what a developer is it's a company that pays for the building and all that goes into creating and designing it, and then they rent the apartment and the units and the retail spaces or restaurant spaces or whatever we end up designing in those. And so projects can take anywhere from 1 to 3 years, depending on how large it is. That is going anywhere from taking an idea or just the thought of a design to the building actually being built on the ground and starting to be used. And because this is such a long process, we break our project into several phases. The first phases start with the design, and then it develops into a very detailed set of documents. These documents can be anywhere from 100 plus pages. And that document, or that set of drawings, explain every single step, every material, every nook and cranny that needs to be built in this building. Then the contractors, or the people who will be outside every day physically building it, the construction team essentially, will read this document and use it to build the building. So if anything's wrong in this document or missing, then obviously something gets built wrong or something is not able to be built. And so it's really essential to have a very complete, very detailed set that we essentially create and design and pass on to the builders. And so the project I'm working on is an apartment building in DC. It has 344 apartments. It's, if anyone's familiar with DC, it's really close to the new soccer stadium, which is only just 2 or 3 blocks from Nats Park. And so this is a very up and coming area in DC. There's a lot of development going on. So it's a pretty exciting project. And I've been working on the project with one other person, sometimes two, since June. And we are about to finish the drawings and such in end of April. So I just thought I would pull up a couple different things to show you the process that goes into building the building. So the project I'm working on is, as I mentioned before, an apartment building in DC. It has 344 units. And what I wanted to show you here is part of the process that I was telling you about, how it goes from a design idea or a concept all the way into a fully constructed built building. And so this is one of the beginning parts of the project, and this is our site, as you can see here. And this is another site that they wanted us to look at that they are going to put a future building on. So they wanted us to see this as almost like brother-sister buildings, and then here's the waterfront over here. So we had some very simple ideas for the design and how we were just starting to lay everything out. We wanted a plaza, we knew that there would be some retail, some residential, some lobby, and of course all of these had square footage is attached. So our client is looking at, specifically since this is a residential building, how many apartments can we get on every floor out of this square feet, right? Because they want to see, they have an idea of how many 1-bedrooms they want, how many studio apartments they want, how many 2-bedrooms they want, and they need to know how big these are going to be so they can figure out how much they're going to rent these for. And so here you can see how just a simple idea of laying out the site brought on some very simple ideas of the building size and how it would look. And this is just if yellow stands for residential, red stands for retail, how much we would need of each. And so then a few months later, the next phase, all of that had been taken and become an actual building. Became more specific, it became more code oriented, and a lot of work and detail had to go in to the building to get it to this stage. And so here it is, you can see we figured out how all the parking is going to work, where and how the ramp systems are going to work, what areas are going to be what in the lobbies, where residential units are going to be, how those units are going to start being laid out, and so on and so forth as we go through the building. And so that was just a piece of showing the different phases at which we work, but to circle back to math, there's a lot of things that I do daily that involve a lot of problem solving. Recently, this past week, I've been working a lot on stair design. I've been working on sloping columns, natural unit ventilation calculations, and ceiling heights and the relation to the mechanical layouts. And so I was just going to pull up and show you. I designed 3 different types of stairs, and I had to figure out how high up they needed to be spaced, knowing that this is a ground floor and all these knew where the next landing was. I had to figure out I needed to figure out what type of steel we were going to use, how big and deep it should be, what the railing should look like, all these different things. And then we took these to the clients and I started to draw up some details and different coordinating things, and these stairs went from just an idea to actual details, in which I had to figure out how wide they should be, how the railings will be placed, what the run of the stairs should be, what the width of the stairs should be, what the tread depth should be, how many stairs we can get in a row, how these interact with the walls around them, what the head heights will be, etc., etc. So developing these into more details, and there's quite a bit of calculation that goes on, even though it seems like such a simple task at the beginning. And so I spent a lot of time doing that. I also recently have been working on something we call unit ventilation calculations. So in DC, there are several different types of requirements you have to meet. Every apartment, by law, by code, has to have a certain amount of operable window. So when designing a building, you start to look at a lot of those different things. So if you're looking at the facade of a building, there are 2 windows in a unit, and so you're trying to figure out what this square feet is, and then you compare it to how many square feet there are in the unit, and you have to reach a certain number. And then there's also some complications added in, of course, because when you have a washer and dryer in your unit or a kitchen in your unit, you have to get the dirty air out of the building. So you have to vent the building, and these vents have to be 3 feet away from your operable window at a minimum. So in this building in particular, we had a ton of glass, which meant that those vents were very close to the operable piece of the window. So it's become a very tricky balancing of calculating all of the natural ventilation we need mixed with keeping a safe distance from the operable portion and the exhaust, and a lot of back and forth with our mechanical consultants and our plumbing engineers and a lot of different people in the team. So those are just two of the things that I've worked on the past couple days with my team coordinating. And so as you can see, there's a lot of different things that go on. Okay, so that was a bit of a crazy kind of long explanation on all the various things I do, or at least two of the tasks that I've been working on this week. And it might not seem like that much math on the front end, but it definitely is a lot. And in the end, as an architect, I was and am trained to not only just be an architect, but also a historian, a city planner, an engineer, and interior and graphic designer, a data scientist, but also perhaps on some very basic levels, even a mathematician. I may not be creating and solving intense equations all day, every day, but math certainly is entwined in the daily work of my profession. And it was kind of hard to see it, but it's actually a lot of fun, and it's very rewarding to see the process. So thanks for listening. I hope it wasn't too long for you guys, and I'll see you soon to answer any questions you have. Thanks, and bye.